Hey guys, today I'm going to be doing a video. Today is going to be a video on a short summary, well not really that short, but a summary of Mechanics 1. Very brief, very quick. I don't recommend you to just use this. This is just to have quick reminders and stuff. But without any further ado, let's get on with the video. Now, where do I start? So first of all, we got forces. Now, forces is a vector quantity. It's got a magnitude and it's got a direction, unlike scalars, which only has magnitude. Another example of these two would be distance and displacement. Distance is just how far you travel regardless of the direction you go, while displacement actually involves the distance that you're going. Another one would be speed, a scalar, and velocity, which is a vector. Another thing you can do with forces, you can add them together because they're vectors, and you can try to visualize it by drawing arrows. You can also break them down into their x and y components using trigonometry, and if you know like the angle that the force is acting upon and stuff like that, you can actually work it out in terms of x and y, and then you can add these together to do some magical stuff. And then you also have two special unit vectors. Unit vector is a vector with a magnitude of 1. Unit vectors which is the I, which is in the x direction, and the j, which is in the y direction. In mechanics, you have a few type of forces that you come across. There's normal forces, which is the force that always acts perpendicularly up the plane, no matter if it's inclined or it's a straight and parallel to the horizontal. Then you got the weights, which is always acts directly downwards, disregarding, doesn't matter what the angle of the plane is, and it's always going to be worked out by weight equals mass times gravitational field strength, which on Earth is 9.8 meters per second squared, or 10 if you want to be a bit inaccurate. Then you've got applied forces like pushing or pulling applied by you. Then you've got the force of friction. Force of friction always acts the opposite direction of the motion, whatever the direction of the object is moving or tend to move. So if it might be moving downwards, the friction will always act upwards, and you can find it using the equation. The friction equals mu times F norm. Mu equals the coefficient of friction. Usually, sometimes it will be given, sometimes you have to work it out using F rict and F norm. And then there's two types of friction. Static is when the object is not moving, it's just staying still, and there's friction on it. Or there's moving friction, sliding friction, when the object is actually moving and there's a friction force acting upon it. Then you've got tension, which usually applies when there's a string or pulley problems and the object is hanging on the string. It exerts a tension upon the string. They can also describe the force as being in equilibrium, which just means all the net forces in all directions, they cancel each other out. And then we've got Newton's 3 laws of motion, which applies to the forces. The first law is that if the net force is 0, that means the force in two opposite direction cancels each other out. F net equals 0. Then there will be no acceleration, which means that the object that's staying still will stay still, or if the object's moving, it will continue moving that same speed. However, then if you actually have an F net, if the two forces in the opposite direction does not cancel each other out, then you would have to use the second law, which is F equals ma, meaning F net, net force, equals mass times acceleration. You'll be given some of the information and you can probably work out the other one that's missing. Then you have got the third law, which states that there's always going to be an opposite pair of forces. When there's one force, there'll be another force acting opposite of it in equal and opposite direction of it. So for example, if I were to push against my hand, the hand is also pushing against me in the opposite direction at the same force, and that same amount of force. And then sometimes they'll be telling you to sketch graphs, or sometimes they'll even give you graphs for you to analyze yourself. Now, when you do actually have a graph, sometimes it'll be a velocity time graph, sometimes it'll be a displacement time graph. Now, if you get a graph of maybe say velocity time graph, you can work out the gradient at a certain point, and that gradient will be the acceleration. Now, if you work out the area under the graph, then that would be the displacement of the object over that period of time. If you have a displacement time graph and you find its gradient, you would find the velocity. You'd find the rate that displacement changes over a period of time. And if you have the velocity time graph, then you have the acceleration, you can find the rate of change of the velocity over a period of time. And it's not just the graphs. If you have the equation, maybe the equation of velocity in terms of time, then you can use a calculus concept, differentiation, integration to work it out. If you've got a velocity equals a function of time, then you can work out the acceleration is derivative of velocity to with respect of time. And if you got the if you want to work out the displacement, then you can go, it'll be the integral of velocity with respect to time. And if you have, and you can keep doing this if you want to go up from displacement to acceleration, you try to differentiate. If you want to go down from acceleration to displacement, you would have to integrate. And then you also got something else called kinematics equation. There's 4 equations for when the object is moving at a constant acceleration on a straight line. 1D kinematics, kind of what we're doing. And this can be also be used for free falls, when the object's only acted upon by the force of gravity, and when the object is acted upon by the force of gravity, the acceleration is always 9.8 meters per second squared downwards. So if you're working up, you have to make that number negative. And also in projectiles, where the acceleration in the x direction in the horizontal axis will be 0, and in the y direction it will also be 9.8 meters per second squared downwards. Depend if you go upwards, obviously, then change the sign as well. Then you got the concept of energy. There's 2 types of energy that you deal with most of the time. There will be potential energy, which is caused when an object is at a certain height, and you can work that out by PE equals mgh, mass times gravitational field strength on Earth, 9.8 or 10 if you want to be inaccurate, times the height in meters. And the unit of potential energy being joules, just like kinetic energy, which is the energy when an object is moving. Kinetic energy equals half mv squared, half times mass times velocity squared. Now if you have an object with a certain amount of energy at the beginning of an action, at the end of it there will be also the same amount of energy in that reaction. It might have turned from kinetic energy to potential energy. Maybe you've just moved the object high up, or it fell and turning potential energy when it's high up into kinetic energy. And that, the fact that the energy is the same is called the law of conservation of energy, that the total mechanical energy stays the same throughout the action, unless it's acted upon by external work. Then the value would change, but it would still change to the same amount that work is being done on or against the motion. Now there's an equation for work, FD cosine theta, force times displacement times cosine of theta. Why cosine of theta? Because that is the angle between the 2 vectors. Force and displacement is 2 vectors. And the cosine theta is because this is actually dot product, because work is actually a scalar, and I explained about dot product and this equation in a bit more detail in another video. If you want to work out the rate of work being done over a certain period of time, you can use the equation of power. Power equals work over time, and because work is in joules, time is in seconds, power is just basically joules per second, or in other units in watts. And you can also play around with the W divided by T equation. You will find out that power is also force times velocity, and that's 2 equations you can use to work out power. And don't forget that in the exams, when you get a question, try draw a diagram if you haven't already. Fill your knowns and unknowns, the ones that you know and you don't know, and then at the very end, after you figure it out, see if your answer makes sense. Maybe you won't get a small force doing a lot of work or something. Like, you have to make sure that it actually does make sense. And yeah, thank you very much for watching my video. That is a very, very quick summary of Mechanics 1, and I hope to see you again soon. Goodbye.